Why is there no xrange function in Python 3? Recently I started using Python 3 and its lack of xrange hurts. Simple example. Python 2, who? Python 3. The results are, respectively, 1.53888,392,448, 3.215,819,835,662,842. Why is that? I mean, why xrange has been removed? It's such a great tool to learn. For the beginners, just like myself, like we all were at some point. Why remove it? Can somebody point me to the proper pep? I can't find it.
Some performance measurements, using timeit instead of trying to do it manually with time. First, Apple 2.7.2 64-bit. Now, Python.org 3.3.0 64-bit. Apparently, 3.xrange really is a bit slower than 2.xrange. And the xrange function has nothing to do with it. Not surprising, as a one-time call to the _eater_ slot isn't likely to be visible among 10 million calls to whatever happens in the loop, but someone brought it up as a possibility. But it's only 30% slower. How did the op get 2x as slow? Well, if I repeat the same tests with 32-bit Python, I get 1.58 versus 3.12. So my guess is that this is yet another of those cases where 3.x has been optimized for 64-bit performance in ways that hurt 32-bit. But does it really matter? Check this out, with 3.3.0 64-bit again. So, building the list takes more than twice as long than the entire iteration. And as for consumes much more resources than Python 2.6+, from my tests, it looks like a 3.xrange is exactly the same size as a 2.xrange, and, even if it were 10x as big, building the unnecessary list is still about 1,000,000,000x more of a problem than anything the range iteration could possibly do. And what about an explicit for loop instead of the C loop inside deck? So, almost as much time wasted in the for statement as in the actual work of iterating the range. If you're worried about optimizing the iteration of a range object, you're probably looking in the wrong place. Meanwhile, you keep asking why xrange was removed, no matter how many times people tell you the same thing, but I'll repeat it again, it was not removed, it was renamed to range, and the 2.xrange is what was removed. Here's some proof that the 3.3 range object is a direct descendant of the 2.xrange object, and not of the 2.xrange function, the source to 3.3 range and 2.7 xrange. You can even see the change history, linked to, I believe, the change that replaced the last instance of the string xrange anywhere in the file. So, why is it slower? Well, for one, they've added a lot of new features. For another, They've done all kinds of changes all over the place, especially inside iteration, that have minor side effects. And there'd been a lot of work to dramatically optimize various important cases, even if it sometimes slightly pessimizes less important cases. Add this all up, and I'm not surprised that iterating a range as fast as possible is now a bit slower. It's one of those less important cases that nobody would ever care enough to focus on. No one is likely to ever have a real-life use case where this performance difference is the hotspot in their code.
Python 3's range is Python 2's range. There's no need to wrap an iter around it. To get an actual list in Python 3, you need to use listRange ... If you want something that works with Python 2 and Python 3, try this.
Python 3's range type works just like Python 2's range. I'm not sure why you're seeing a slowdown, since the iterator returned by your xrange function is exactly what you get if you iterated over range directly. I'm not able to reproduce the slowdown on my system. Here's how I tested. Python 2, with xrange. Python 3, with range is a tiny bit faster.
One way to fix up your Python 2 code is
If you want to see more, please consider subscribing.